Hi everyone. Okay, I just want to go through a little bit of proportion theorem. So if we have, and similarity, if we have a triangle, okay, and let's say we have A, B, C, D, and E, and they ask us to prove similarity in triangle A, B, E, and triangle A, C, D. You're going to say, in triangle ABE and triangle ACD, and that's very important to say in, okay? Angle A equals angle A, common. Angle B1 is equal to angle C, corresponding. And angle E is equal to angle D, either corresponding or third angle of triangle. Therefore, triangle ABE is similar to triangle ACD, angle, angle, angle. And we have to remember the ratios, and this is what I want to just make sure that you all know, is that AB, if you look, remember AB over AC, so AB over the big one, is equal to AE over AD, AB over AC is equal to AE over AD, and it's equal to BE over CD. So it's also equal to that over that. So remember, you have to look at those ratios. If we had to do, for example, proportion theorem, remember, proportion theorem is just with your parallel line, divides sides in proportion. So we could also use the theory that AB over BC is equal to AE over ED, or AB over AC equals AE over AD, which your similarity gives you, or CB over CA is equal to DE over DA. All right, so that's how your parallel line divides sides in proportion. Now, a very important thing what they do is they ask us area, and this also people don't like. So if we have our basic A, B, C, D, and E, our area of triangle ABD over area of triangle ACE is half AB times AD, sine of A, because A is common, over half AC times AE times sine of A, because A is common. The sine A's will cancel. The sine A's will cancel. The halves will cancel. And we have got, therefore, whatever the values are, AB times AD over AC times AE. All right. So then we've got area can come up also if we have a triangle A, B, C, and they have the same vertex, the same corner. In this case, we won't use half A, B, sine C. We won't use the area rule. If two triangles have the same vertex, which means corner, then we use half base times perpendicular height, because they both have the same perpendicular height. So you would say half, let's call that T, you'd say half BT, the base, times height over half TC times height, and in the area of triangle ABT over your area of triangle ATC is going to be BT over TC. Okay. What I'll do is I'll also show you we'll go through a sum that you had in your geometry test. that looked like this. Okay. And we had that those were parallel and those were parallel. And the main thing I want you to understand, remember, is that you could also get same angles using alternate or corresponding. Okay, which means, remember, it's only a common if it is exactly the same angle. If we're dealing with triangles that we've proved angles are the same using alternate or corresponding, then, so for example, if we look at this picture here, that angle there will be equal to that angle there because of corresponding angles. Okay, so in the next slide, we're going to go through the sum that was in your test, and I'll show you how to go through proportion theorem and area, and a few of you got those concepts wrong, so we will go through it and you can look at it. Okay, so let's look in this triangle. We've got triangle ACF. This was in your test a few months ago. You've got parallel lines AE and BD, and you've got parallel lines AF and BE. And they tell us AB to BC is 2 to 5. Now, a lot of people in this test also, when they ask for ratios, they didn't write it as a ratio. You will lose marks. If they say a ratio means it's got these dots. Okay, so they ask us for two other ratios. Now, if you look, we've got a big triangle, ACF, and the parallel lines AF and BE, and we've got a small triangle, AEC, with those parallel lines, AE and BD. So let's look at the big triangle, AFC. We've got AB over BC is equal to AE over EC. And let's call that 2K and 5K. So we use the ratio 2 and 5, but we call it something else. So we're going to say FE to EC is equal to 2K to 5K, which is 2 to 5. Okay? If we look in the green, with the green parallel lines, and it's easiest to see where the lines are equal, because where that parallel line, the baby parallel line equals, it's what cuts the ED and DC, for example. So you're going to say AB to BC is equal to ED to DC, which will also be 2 to 5. And let's call this one 2P and 5P. Okay, so that was the first question. Found two other ratios, and your reason is parallel line divides sides in proportion. Then it says find, so let's write this question B, find in simplest form ED over FE. So let's look at the picture, ED over FE. So if you look at ED, it's 2P, and FE is 2K. You can't have P's and K's equal. So we're first going to try and equate this. We're going to equate the 5K, which we know is EC, and it's equal to 2P plus 5P. So let's write that down. We're going to say 2P plus 5P equals 5K. So 7P equals 5K. So let's get 7P over 5 equals K. So now we can say ED is equal to 2P, which is 2. We don't want P, so let's rather get this one at the top here. Instead of finding K, let's say P is equal to 5K over 7. So it's going to be 2 times 5K over 7, which is 10K over 7. So now we can say ED over FE is equal to, ED is 10K over 7 over FE, which is 2K. And the K's are going to cancel, and you're going to have 10 over 7 over 2 over 1, so times by 1 over 2, which is 10 over 14, or 5 over 7. Okay, so you have to remember that you're looking at it, you're writing the ratios with K's or P's to make them equal, and then you equate it. You can't have P's and K's equal. Okay. Then, let's just make this, let's keep it on the same page so we can make it smaller. It says, write down the ratio of BE over AF. So if we look at the diagram, we've got BE is over there and AF is over there. Now, we did it in the very, very beginning of this video. Okay, I showed you with that similarity that that over that is equal to that over that. Okay, so small over big. So if we look at the big triangle AFC, the small side is BC. So we're going to say the small side is 5 and the big side is 7. So we're going to say BE over AF is small side, which is 5, over big side AF, which is 7. So it's 5 to 7. Okay, and that's also a parallel line divides sides in proportion. Okay, so it's purely using your similarity rule or your proportion. We know that the small side over the big side is equal to small side over big side. And know that ratio. Know it, please, 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 please. Okay, and then it says, number D, hence or otherwise find the area of triangle BDE over area of triangle AEF. BDE, so this small triangle, and AEF. So if we look, and this is what I explained with the area just now, there's no common angle. The angle, and a lot of people when they answer this question, they use half AB sine C, which I know that that's what you've been drummed, but there's no common angle. The angle is not exactly the same. Okay, it's not lying one on top of each other. There is a common angle. These are two triangles. There's a triangle there, and there's a triangle there. They're not the same triangle. But what you can see, we can see that that angle A and that angle B are corresponding, and we also know that that angle there and that angle there are corresponding. So you can say angle A1 is equal to angle B1 because of corresponding angles. Okay, so you could have explained it in much more detail. You could have said A equals B corresponding angles, and then A2 equals B2 corresponding angles, so therefore A1 equals B1. All right, so we could have gone into more detail, but basically those angles are equal because of corresponding angles. Okay, so you either label A1 and B1, or you can label FAE and you could have used FAE is equal to EBD, so we could have used that, or we could have gone into even, but then we're going to have to find the ratios of BD and AE, or we can go and say that AFE, the bottom angles, are equal to BED. So it doesn't make a difference as long as you're going to get the side. So if we look, we've proved BE and AF. We know BE is a ratio of 2 and AF 2 to 7. So BE and AF is 2 to 7. We don't have BD and AE, but that would also be 2 to 7. Okay, so if we want to do it with the first two angles that I said, we can say area of the BDE is going to be half BE, which is 7, and BE is, 2, and BD is also going to be 2, and we're going to say sine B1 over half AF, which is 7, and BE, which is going to be 7 in the other triangle, sine A1. And because B1 and A1 are equal, those are now going to cancel. The halves are going to cancel, and we're going to have 4 over 49 is my answer. So you have to be very careful. You can use half AB sine C, but you have to make sure you have the correct angles. So that was the question in the test that we wrote just before lockdown. Please go through it. Please understand your ratios, which sides. Please understand to use variables like K and P. So although the ratios are the same, they're not the same number. And go over it clearly. Send me a message if you need any questions, and good luck for your exam.